Hey, thanks for joining, and this time I'm really happy to present to you a new offering of Bitbybit called Bitbybit CAD Cloud. This is a new system that allows you to purchase API keys and execute algorithms on the cloud, on managed servers of Bitbybit. So these cups here that you see, they represent something major. This time they were computed on the cloud, and let's look at how that works now. So let's start with the location. Okay, we're at studio.bitbybit.dev. This is a gateway to API of Bitbybit. So bitbybitdev itself is here. Okay, this is where you find our visual coding editors and everything, but Studio is where you get an access to our CAD cloud. When you go hit this sign in to get started, you will be asked to create an account with Bitbybit, and I already have one, so I will just sign in with Google. After I log in, I'm redirected back to the dashboard. Users that don't have a subscription on Studio will be redirected to this billing page. And here you are presented with your information about the account. So how many minutes have you ran your computations, right? So what's the usage of your API keys? You can see how many API calls you've made, things like that. So this is the place where you manage your API keys, see the tasks that you ran, and the playground of the Studio allows you to inspect what are the possibilities of the API, right? You use API in your applications, in the backend applications. You don't really need the Studio, but Studio helps you, right? So Studio is where you can look what kind of tasks have you ran or your users ran when they were communicating with Bitbybit CAD Cloud through your API keys. So let's just try and run one simple example, which will maybe show you what are the possibilities. So let's go with the models, right? So these are the models that are pre-programmed in Bitbybit CAD Cloud that you can run yourself from your own applications. And I will choose this batch mode, and I will load the preset with 12 different models, okay? What you see here is the table of all kinds of parameters of these cups that you saw in the very beginning, okay? So each of those is unique and different, and you can add more. You can even download this table as a CSV template, and then you can also upload a CSV template, right, to define all the parametric permutations of your models. So here on the bottom, I can choose what kind of formats do I want to save into. So glTF and step seem like good ones. And what I will do now is I will just hit this generate 12 models, and the server kicks in, okay? The compound task that runs parallel tasks has now started. And you see that now 5 processes are running. I'm on the plan that allows me to run 5 concurrent tasks. There are plans that allow more compute. Basically, it just depends on the plan that you will be subscribing to. But you see that now the computations are running and these cups are being generated one by one, right? All of those table items defined each model. And now the server is just running and computing and queuing the tasks, doing all kinds of things that are really interesting. But in our situation, we just wait, till the last task is finished. You see the percentage here as well. So we're still running these computations. And you see that, the task is computing in 5.6 seconds, 34.5. This means that it just depends on your parametric configuration of the model, right? How long the algorithm will take. And the lighter algorithms will compute faster. The heavier ones, like the last one, as you see here, will compute a bit longer. I'm not exactly sure what is the deal with that particular algorithm, but this is how long it took. And now, when all of these tasks are finished, we can inspect them. So we can just go ahead and preview one single model that we've generated. So this is a single cup, right? We can go back. We can look into another permutation. Let's pick a more complex one. Yeah, okay, this is also still simple. Let's try something, maybe model 2. Let's see how that looks like. Oh yeah, that one is really cool. And a nice thing about it is that you can as well open all of them in one 3D view and just preview them laid out in the scene. So you see here that all of these permutations, 12, right, 3 by 4, 12 different configurations have been computed. So you can enable ground here, look around, check what kind of models these are. You can also look and hide them. So this viewer is just a helper for you to navigate your models. What is important though is that you can go ahead and download metadata about this object that was also pre-generated. You can download step Z files, GLB files. So step Z you can open in FreeCAD, right? It's a step file. And we can produce complex assemblies as well on this cloud. Now, I think it's a good idea to talk a little bit, why am I showing you how to compute a cup? So Bitbybit CAD Cloud is split into few parts. Of course, we have algorithms that are generic, right? You can tap into them by using any programming language. Just call our API via REST, and you'll be able to communicate with the server. So you may choose things like, maybe you want to just do a boolean operation on a sphere, for example, and a box. And we have even an example here for that. So here you can build pipelines in this playground. These are simple pipelines meant just purely as an example. But what you will recognize here are things like OCCT shape, solid, create shape. This is an API of Bitbybit that you're familiar with from the front-end side of Bitbybit, right? Our coding editors like Read and Monaco have those. So if you go here, for example, into the Read, it's shapes, solid, and then primitives have a sphere somewhere. Let's see, do I have it here? Yeah. So here we have OCCT shapes, solid, create sphere, and we create a sphere in the front end. So this sphere was computed by the browser, okay? Here I will run this computation on the CAD Cloud, and I'll just do a GLB and step files. Let's do that. Execute. So now single task was created before we saw a complex task because we were running batch computation. But in this case, we executed a generic CAD compute. We generated step file. Let's just download that file for now. Let's download. And let's open it up in FreeCAD. Okay, so in FreeCAD, we just opened the result, and it's a sphere which has a square cutout. It's a very basic model, okay? Don't think that I don't understand that. But the important idea is that you can run these generic CAD computations on our cloud as a user. So as a programmer, you can just do that. Let's close it. Another thing that you can do is you can convert files like from step to glTF, for example. So you also don't need any front-end library to do that. You can just use our CAD compute and build applications, backends for your users that can do that. So this, just to make it clear, okay, this system is meant for developers that are developing applications on backends. API keys that you're getting, those are like passwords. You never include them in front-end applications. Otherwise, they get stolen, right? People can run compute on your account and you will be the one paying for it. So keep your API keys secret in the backends, in environments, in environment variables or environment secrets, even better. So this is one way how the system works. If you are someone who wants to develop custom geometrical algorithms and put them on the cloud, well, then you need to go through us and we can work together to put your code and logic onto the CAD Cloud. We do not allow you to publish your visual scripts to the CAD Cloud. We just simply don't trust code from third parties. We always will be reviewing what we put it there. What you can do then is we support tenants. So basically, if you're an enterprise customer, you have a special role assigned that is a tenant-based. That tenant-based computation will be only available to your API key. You'll be able then to run the compute on our cloud infrastructure in a similar way that I ran now these algorithms. By the way, these algorithms as well are available to you as a user, right? You can generate these models from your backend applications. But if you're a tenant on our cloud infrastructure, then you get to also use your own custom 3D parametric models, for example. So this is a bit of a long story of how that works, but let's look into the practical example. So we were watching now this whole application that is called Studio bitbybitdev, right? If someone steals your API key, you go here, you revoke it, you rotate it, whatever, you just make it unavailable so that no one runs compute on our infrastructure through your account. But if you are a developer, of course, you will be using our API through custom code. And let's look into the app that is doing that now. If you will need to write an application that uses our CAD Cloud, you will probably need some examples, and you can find them here in our mono repo, where we publish all open examples. And here under API, we have now two apps, Honor REST and Node.js REST, which show you how you can interact with our API via an actual application, okay? So if you open the code base here, you'll see that we have an example of environment. So the API is api.bitbybitdev, and here you enter your purchase key, okay? You can, of course, read this documentation on how to set it up, and then you'll just run it on localhost 3000. So I have this code base. In this application, you will see, the same .env. Your key is here. In the package.json, you will not find anything related to BitByBit, not even 3.js. Okay, 3.js we used just for an example in this front-end route. It's just a simple scene that will use the models. But the idea is that you have this client, and the client has possibility to talk with our API. And you see here that we're calling Dragon Cup with these parameters. So this is an app that we will be running, and it will have two modes. One will generate one cup, and another mode will generate a Dragon Cup in batch. So there will be 3 cups generated here. These are sort of hello world applications, okay? Don't think that they are really fancy or something. But here we will just go and enter our API key and run the server. So I'll do that now. I've just entered the API key, restarted the server, and we can now go into the localhost. And here you see the app with 2 buttons, generate Dragon Cup and generate batch, 3 variations. So let's first run this generate Dragon Cup. I'll hit it, and now it's running, and you can even see it here. So I ran my computation from my own application via the API key, and here I can inspect this task that is now currently being executed, right? So each thing that you do with the API, it runs with this tasks, and you can even inspect that model here. But because I know that it's now finished, I also know that it has finished here as well, right? So this is quite cool, I think. If you refresh this model, you will see it again, because that glTF file that we've generated, it comes from our cloud storage. The models, by the way, are saved for 24 hours, and after that they get purged. your backend has to take care of those models. If you want to save them to your own cloud storage, do that. If you don't need it after the computation finishes, they will get wiped out eventually. So we don't basically hold these tasks forever. We clean them up. The idea is that you wait till they finish. You can poll your tasks so you know when they're done. This is made, what I mentioned, also for long-lasting computations, right? Not something that you can spit out in a second. And now I will just, remove this task because we already computed it. Let's run this batch with 3 variations. And now I started another task. So if I go here to the studio, you'll see that now it's running. And this is a batch computation. One is finished, another is finished. And after they all will get done, I'll see a completed parallel task where everything is done. So that took 14 seconds in total. And let's see, this is the result. So we positioned these, in code, but if we wouldn't have positioned, they would just overlap. And you can also inspect the same result here with preview all in 3D. So here you'll see them all in one place, okay? You can use the slider to move them away from each other. And also we have here another some fun thing like a ground. And we can even disable this nesting, right? So in this way, they all just come into their original positions. So nesting is just something that moves those parts away from each other so you can get a better overview of the things that you're computing. But imagine that your parts are, individual pieces on a facade, for example. Then probably you would, in the algorithm, define something like world coordinate, and you would compute your part designs, and then they would be placed into their good orientations in each file. And probably then this nesting wouldn't be required. You would be able to look into them from one side. So again, this is made for something like large, complex geometries. Those cups are illustrative, right? But they maybe don't illustrate the fact that what happens if you need to run long computations on the cloud. And in this case, you don't want to use the front end. You don't want your users probably to use browser and wait till computations finish in some browser tab. But yeah, this is a very interesting new direction of BitByBit. So mostly now I spoke with enterprise customers. They see a big value in that, but of course I made it available to all BitByBit subscribers. You have to, of course, accept the terms, right, in the very beginning. So you must have an account with BitByBit to use the API. I really think this is something that can be used in many industries, but mostly I talked with clients from manufacturing, and that's where these kinds of model generations, parametric model generations, make a lot of sense. Imagine, you need, thousands of models, in some cases, maybe parametrically you defined unique elements in your assemblies, and that may need, 2,000, 3,000 individual models that are all different by, 1 millimeter of length or something. In these cases, you do need to run those computations in batches on the distributed cloud infrastructure. And this is what we will be providing from today, basically, right? So let's talk about pricing. This is not a free solution, okay? You cannot run cloud computations for free on our managed servers. It costs money, and here is the starter plan where I think most of the people who want to experiment should go and purchase. So it doesn't have any overage, this is a fixed amount that you pay per month. And these plans are based on the compute that you get to use per month. Later on, more diversifying factors will be added, but for now, this is the only difference basically. And also they differ by the file size that you can generate. We have basically those conversion algorithms, right? And if you use big files, then probably you need something like that. Also, the average of these professional and business plans is bigger, right? So let's say I think you would use them in the situations where you're already going into production and you want to, for example, serve more customers. So you will run naturally more compute, right? Because more users will be triggering these algorithms. You're not testing anymore. So these are the plans then that are more interesting for you probably. If your idea is to run a custom algorithms on our cloud infrastructure, then contact us. We will discuss how to do that in the best possible way. Usually it involves some custom software development contract, enterprise relationships between our businesses. And then we put your code into our cloud. You get to call our backends. They do the CAD 3D computations. You get the answers, 3D models, whatever that is, save them to your own databases, and we're done. So basically, the idea is that enterprise customers that need to run custom workloads, contact us and we help you get there. Maybe you're someone who's using our free CAD editors, right? Maybe you already have algorithms prepared. In that way, our job will be a bit easier to transform those algorithms into performing, well-built code, and we will put them on the cloud infrastructure. So this is simple. By the way, these editors, right? These editors on BitbybitDev, they're still free and open for everyone. You can experiment with algorithms, and the best part is that all of these algorithms are available on the CAD cloud. Okay, so you can go, and you already saw, you can create solids, you can create boxes, you can create spheres. So whatever you find here, you can also use via the studio and via your API keys. You just need to know the address of those algorithms. So if you want to create a box, right, you will need this algorithm in your pipeline. So yeah, if you want to learn more, you need to go to to our cloud API docs. It's here under Learn BitbybitDev API Cloud API. And here you can read about a lot of stuff, like we are preparing an SDK for TypeScript that's gonna help you develop those Node.js and Hono applications, for example. We have here explanations about the studio, and of course the API reference as it is now. It's definitely gonna evolve. This is the first release of the API, so many things are still moving, but the important thing is that it all works. You can use it today. You see here also that you can call the API from many different languages. Okay, so this is a REST API, RESTful API. That's why this is possible. And yeah, there will be a lot more tutorials in the future. This is more of a announcement video tutorial, okay, about this whole offering. Yeah, I hope you enjoyed it, and I hope to see you later in another videos. Cheers.